name's Joanie, your Geospatial Data Analyst. Today we're diving into a practical case study on the Normalized Difference Vegetation Index. Using Geospatial data in R, we'll walk through all the steps of loading, processing and analyzing satellite imagery data to assess vegetation health. Whether you're new to NDVI or looking to refine your geospatial analysis skill, this session will give you hands-on insight into working with remote sensing data. Let's get started! To compute the NDVI index, we will first need to load the data. I also like to visualize the data every chance I get, so I can be sure that everything works properly. NDVI index is a form of spatial operation that we will need to perform to get the result we need. And of course, we will export the results. So, with the package SF, we have access to a function called stread. With this function, we can load a shapefile in which there is a polygon. In this case, it's a polygon, is the border of a region in Quebec called Le Binière. The function plot here helps us see that in the object called region that we have load from the shapefile, that we effectively have the data we need. So this first step is to identify the polygon of the region for which we need the NDVI index. Next, which is the most interesting step, is to use the RSI package. The RSI package gives us access to many functions to access different satellite data. Here I chose to get Landsat imagery. I choose to keep it simple here only by specifying the region and a start date and an end date. You can of course get really more precise in the query you want by adding option to your function. So if you run this API, you are going to get an object which is saved on your computer. From this object, you can read it with the terra package, so the function raster, to obtain an object in your environment that you can plot. So here I choose to read the Landsat object and plot only the R and the N layers. So the R is for red and the N stands for near infrared. There is many more other layers in the Landsat object, but for the NDVI we need only the red and the near infrared layers. Now that we have those two information, it's time to crop or mask the spatial raster in the form of the region that we previously choose. So the first thing we need to do is to be sure that the region has the right CRS. The right way to do it is just only to apply a ST-transform function to the region data or the region polygon, and to be sure that this CRS match the CRS of our raster object. After that, we can simply use the mask function to apply to our spatial raster object the polygon region. And if they have matching CRS, we can just plot this new Landsat region object, and we can see that the spatial raster is now cropped or masked in the shape of our defined region. Okay, so we have defined the region. We have some interesting data from the red and the near infrared layers of a spatial raster. Now it's time to compute the NDVI. So the NDVI is the near infrared layers minus the red infrared layers divided by the near infrared layers plus the red infrared layers. NDVI is a widely used metric for quantifying the health and the density of the vegetation using sensor data. So, an area with nothing growing in it, we have an NDVI of 0. The NDVI will increase in the proportion of the vegetation growth. An area with a dense and healthy vegetation will have an NDVI of 1, and this value will be less than 0. That's going to suggest a lack or a dry land. And any kind of water will have an NDVI of -1. So if we take here our calculated NDVI and we plot this, giving it a nice title, we obtain a spatial raster of a computed NDVI in which we have here everything that is in light green and yellow. That's representing dense vegetation, and everything that goes more towards the blue, representing less dense vegetation or near water situation. So now that we have our NDVI, the last step or the proper way to save our result is just to export it into an image, so a TIFF. To do so, we can use the write raster function, include the name of the file that we want to save, and gives it the path. So here I'm just saying that I want my calculated NDVI to be saved in my data folder with the name NDVI and in the format of a TIFF file. So that's it. We have learned how to load, process, and export geospatial data in R. We have computed the NDVI for the region of Lotbinière. This index is a useful tool to monitor vegetation health and growth. So if you got any question or thought about this topic, drop them in the comment section below. I'd love to hear from you and help out however I can.